Good evening, and welcome to SoothingSoundLoop. Tonight we will embark on a comprehensive and methodical examination of paint drying processes across 12 different surface materials and paint combinations. This detailed observation will guide you through the complete transformation of liquid paint coatings as they cure and reach their final dried state. We begin our extensive observation with standard latex paint applied to a smooth drywall surface that has been properly prepared with primer. The paint selected is a high-quality interior latex in an eggshell finish, applied with a standard 9-inch roller using a 3/8 inch nap sleeve. The coverage rate is approximately 400 square feet per gallon, applied in a thin, even coat using the standard W pattern technique. At minute 0, the paint exhibits a uniform wet sheen across the entire surface area. The color appears approximately 15% darker than its final dried state due to the moisture content present in the coating. Small roller marks are clearly visible, creating a subtle texture pattern that catches and reflects the ambient lighting in the room. The paint flows smoothly and shows excellent leveling characteristics. At minute 2, we observe the very beginning stages of the drying process. The paint maintains its wet appearance, but careful observation reveals that the surface is beginning to lose some of its mirror-like reflectivity around the thinnest areas, particularly near the edges where the coating naturally tapers to its minimum thickness. At minute 5, the initial flash-off period has begun. The paint's surface is starting to lose some of its glossy appearance, particularly around the perimeter areas where the coating is thinnest. The water-based solvents are beginning their evaporation process, causing the paint molecules to draw incrementally closer together as the coating begins its transformation from liquid to solid state. At minute 8, approximately 20% of the surface now shows signs of initial surface drying. The paint exhibits what is technically known as the tack-free stage in certain areas, meaning it no longer adheres to a clean finger when lightly touched. However, the majority of the surface still maintains its wet appearance and remains in the early stages of the drying process. At minute 12, we observe continued progression in the drying pattern. The paint is developing what coating professionals refer to as a skin formation on the topmost layer. This thin membrane allows the underlying paint to continue its curing process while protecting the surface from dust and debris contamination. At minute 15, approximately 40% of the surface has achieved the initial dry-to-touch stage. The color is beginning to lighten slightly as water molecules continue their steady evaporation into the surrounding atmosphere. The roller texture is becoming more pronounced as the paint film contracts during the drying process. At minute 20, the majority of the surface now displays a matte finish characteristic of the drying phase. However, several small areas where the paint was applied more heavily, particularly around the roller overlap marks, still retain a slight sheen, indicating they require additional drying time to reach complete surface cure. At minute 25, we note that the paint has achieved uniform surface drying across 90% of the application area. The few remaining wet spots are primarily located in corner areas and along the bottom edge where gravity may have caused slight accumulation of the coating material during application. At minute 30, the latex paint on drywall has reached what is considered dry to touch throughout the entire surface. The coating will continue to cure and harden over the next several hours, but for practical purposes, the surface is ready for light use and protection from environmental contamination. Moving to our second comprehensive observation, we examine oil-based semi-gloss paint applied to a carefully prepared pine wood surface. The wood substrate has been meticulously sanded to 220 grit smoothness and treated with an oil-based primer coat 24 hours prior to the top coat application. The primer has been allowed to cure completely to ensure optimal adhesion of the finish coat. The oil-based paint demonstrates superior flow characteristics as it moves smoothly across the prepared wood surface. The formulation's longer open time allows for excellent brushwork and the elimination of visible brush marks through proper technique. The paint penetrates slightly into the wood grain, creating enhanced adhesion and a more uniform final appearance than would be achieved on raw wood. At minute 0, the initial application shows the paint flowing beautifully into the subtle wood grain pattern, effectively filling minor surface irregularities while maintaining the natural character of the pine substrate. The oil-based formula provides superior penetration and mechanical adhesion to the wood fibers compared to water-based alternatives. At minute 5, the paint surface remains completely wet and maintains its full gloss level. This extended open time is characteristic of oil-based formulations due to their chemical composition and the oxidation polymerization process required for proper curing. The surface reflects light uniformly across the entire application area. At minute 10, there is minimal visible change in the paint surface appearance. The coating remains wet to the touch and maintains its mirror-like gloss finish. This behavior is entirely expected and normal for oil-based paint formulations, which require significantly longer drying times compared to latex alternatives. At minute 15, we continue to observe the wet, glossy appearance with no significant changes in surface characteristics. The paint remains in its liquid state, allowing continued flow and self-leveling to occur naturally. At minute 25, the first subtle indicators of surface film formation begin to appear. A very thin skin is starting to develop on the topmost molecular layer of the paint film, though the underlying material remains in liquid form and continues its slow curing process. At minute 30, the surface skinning becomes slightly more pronounced, though the paint remains wet underneath this thin protective layer. This is the beginning of the complex oxidation process that will eventually transform the liquid coating into a durable, hard finish. At the 45-minute mark, we observe continued development of the surface skin, which now provides some protection against dust settling, but still allows the underlying paint to continue its chemical curing process. The gloss level remains unchanged. At 1 hour, the surface skin has become more substantial, though careful testing reveals that the paint underneath remains soft and continues to cure. Oil-based paints typically require 4 to 6 hours to reach true dry-to-touch status. Our third detailed observation focuses on high-quality acrylic paint applied to a properly prepared aluminum surface. The metal substrate has been thoroughly cleaned with industrial degreasing solution, lightly abraded with fine steel wool, and primed with a specialized metal primer designed for optimal adhesion to non-ferrous surfaces. The acrylic paint spreads evenly across the smooth aluminum surface, demonstrating excellent flow characteristics and self-leveling properties. The coating exhibits superior adhesion to the properly prepared and primed metal substrate. The surface maintains a uniform wet appearance immediately following application. At minute 3, we begin to observe the characteristic flash-off period where organic solvents begin their rapid evaporation from the paint film. The surface starts to lose its completely wet appearance around the perimeter of the painted area where the film is naturally thinner. At minute 7, the acrylic coating continues its transition from wet to dry state. The paint exhibits faster drying characteristics compared to oil-based alternatives due to its water-based carrier system and advanced acrylic polymer chemistry. Surface tension remains optimal for good flow and appearance. At minute 12, approximately 60% of the surface has begun to achieve a matte finish. The acrylic resin system provides excellent durability and weather resistance characteristics that make it ideal for metal substrate applications. At -18, the paint has achieved uniform surface drying across the majority of the application area. The acrylic polymer chains are beginning their cross-linking process, which will continue for several days to reach maximum hardness and durability. At minute 25, the acrylic paint on aluminum has reached dry-to-touch status throughout the entire surface area. The coating will continue to cure and develop its full performance characteristics over the next 24 to 48 hours. Our fourth comprehensive observation examines high-build masonry primer applied to a prepared concrete surface. The concrete substrate has been properly cleaned of all loose material, dust, and efflorescence. Any cracks or surface imperfections have been filled with appropriate concrete patching compound and allowed to cure completely. The masonry primer demonstrates excellent penetration characteristics as it soaks readily into the porous concrete surface. This deep penetration is essential for creating a proper foundation for subsequent top coat applications. The initial application appears slightly irregular as the concrete absorbs the primer at varying rates depending on local porosity variations. At minute 5, the primer continues to be absorbed by the concrete substrate at different rates across the surface. Areas of higher porosity show more rapid penetration and faster initial drying, while denser sections of the concrete retain more surface primer and require longer drying times. At minute 10, we observe the primer beginning to achieve more uniform appearance as the initial absorption phase nears completion. The coating is sealing the concrete pores and creating the proper surface profile for optimal top coat adhesion. At minute 15, the primer exhibits continued absorption into the substrate while simultaneously beginning to form a protective film on the surface. This dual action process is characteristic of high quality masonry primers designed for porous substrates. At minute 22, the primer has achieved a relatively uniform matte finish across most of the surface area. Some variation in appearance remains due to the natural variations in concrete porosity, but the overall coverage is becoming more consistent. At minute 30, the primer has reached dry-to-touch status and has effectively sealed the concrete surface. The substrate is now properly prepared for top coat application, having been sealed against moisture penetration and provided with an appropriate base for subsequent paint layers. Our fifth detailed observation examines two-component epoxy paint applied to a properly prepared steel surface. The steel has been sandblasted to white metal cleanliness and immediately primed with zinc-rich primer to prevent corrosion. The epoxy top coat is mixed according to manufacturer specifications with a pot life of approximately 45 minutes. The epoxy paint flows smoothly across the prepared steel surface, exhibiting excellent wetting characteristics and superior adhesion properties. The coating self-levels effectively, eliminating brush marks and creating a smooth, professional finish. The chemical cure process begins immediately upon mixing of the two components. At minute 0, the epoxy coating displays perfect gloss and flow characteristics. The chemical reaction between resin and hardener has begun, though visible changes will not appear for several minutes due to the coating's extended working time. At minute 8, the epoxy maintains its wet appearance and full gloss level. The cross-linking reaction continues at the molecular level, though surface characteristics remain unchanged during this initial phase of the cure cycle. At minute 15, we begin to observe the first subtle signs of surface film formation. The epoxy is transitioning from its liquid state toward gel formation, though the surface remains wet and workable for touch-up if necessary. At minute 25, The gel point approaches as the epoxy coating begins to lose its flow characteristics. The surface maintains its gloss but is becoming less susceptible to movement or flow patterns. At minute 35, the epoxy has reached gel point and no longer flows or self-levels. The surface remains glossy but has achieved dimensional stability. The curing process will continue for several hours to reach full hardness. At minute 45, the epoxy coating has progressed beyond gel point and is developing increasing hardness. The chemical cure continues, building cross-link density and developing the coating's ultimate performance characteristics. At 1 hour, the epoxy paint has achieved dry-to-touch status, but will continue curing for 24 to 48 hours to reach maximum hardness and chemical resistance properties. Our sixth comprehensive observation focuses on flat latex paint applied to a textured plaster surface. The plaster has been properly aged and sealed with appropriate primer to ensure uniform absorption and optimal paint performance. The texture provides additional surface area that affects drying characteristics. The latex paint flows into the texture valleys while maintaining coverage on the raised areas of the plaster surface. The textured substrate creates varying film thickness across the surface, with thinner films on high spots and heavier applications in the recessed areas. At minute 3, we observe differential drying beginning to occur. The thin films on texture peaks begin losing their wet appearance first, while the deeper areas retain moisture longer due to increased film thickness and reduced air circulation. At minute 8, the texture pattern becomes more pronounced as drying progresses. High areas achieve matte finish, while valleys remain wet, creating an interesting visual pattern that will eventually normalize as drying completes. At minute 15, approximately 70% of the surface area has achieved dry-to-touch status. The remaining wet areas are primarily in the deepest texture valleys, where air circulation is limited and film thickness is greatest. At minute 22, the textured plaster surface shows continued progress toward complete drying. The variation in drying time across the texture creates an interesting study in how surface geometry affects coating cure characteristics. At minute 30, the latex paint on textured plaster has achieved uniform dry-to-touch status across the entire surface area, including the deepest texture valleys. The coating will continue to cure and develop full hardness over the next several hours. Our seventh detailed observation examines penetrating oil-based stain applied to raw red oak lumber. The wood has been sanded progressively through 180 grit and cleaned of all dust to ensure uniform stain penetration and appearance. The oil-based stain penetrates deeply into the oak grain, enhancing the natural wood character while providing color enhancement. The stain flows readily along the grain direction and soaks into the end grain areas more readily than face grain sections. At minute 5, the stain continues its penetration process, with end grain areas showing darker color development due to increased absorption. The face grain maintains more surface stain while gradually absorbing the penetrating oils. At minute 10, we observe the characteristic darkening effect as the stain interacts with the natural tannins present in the oak wood. The penetration continues at a steady rate, with some surface stain remaining for extended working time. At minute 20, the stain penetration has reached equilibrium with the wood substrate. Excess surface stain can be wiped clean, leaving the absorbed stain to continue its slow drying and curing process within the wood fibers. At minute 35, the surface stain has largely evaporated or been absorbed, leaving a uniform colored appearance that enhances the natural oak grain pattern. The penetrating oils will continue to cure over several hours. At 1 hour, the oil-based stain has achieved its characteristic appearance and is ready for top coat application if desired. The penetrating oils have established good adhesion within the wood structure. Part 8. Water-based polyurethane on maple flooring. Our 8th comprehensive observation focuses on water-based polyurethane floor finish applied to properly prepared maple hardwood flooring. The wood has been sanded with progressively finer grits through 120 grit and thoroughly cleaned of all dust contamination. The water-based polyurethane flows evenly across the smooth maple surface, creating a thin, uniform film that will provide excellent durability and appearance. The coating exhibits rapid initial flash-off of water content. At minute 2, we observe the beginning of the rapid drying characteristic of water-based finishes. The surface begins to lose its wet appearance around the perimeter areas, where film thickness is minimal. At minute 6, approximately 40% of the surface has progressed beyond the wet stage. The water-based system dries much faster than oil-based alternatives, making it suitable for commercial applications requiring rapid turnaround. At minute 12, the polyurethane coating has achieved dry-to-touch status across most of the surface area. The clear finish enhances the natural maple grain while providing protection against wear and moisture. At minute 18, the water-based polyurethane has reached complete surface drying. The coating will continue to cure and develop full hardness over the next 24 hours, during which time foot traffic should be minimized. Our 9th detailed observation examines alkyd-modified latex paint applied to fiber cement siding that has been properly primed with masonry primer. The alkyd modification provides enhanced adhesion and durability compared to straight latex formulations. The alkyd-modified paint flows smoothly across the fiber cement surface, providing excellent coverage and hiding power. The coating exhibits good flow and leveling characteristics, while maintaining faster drying times than traditional oil-based paints. At minute 4, we begin to observe initial surface drying around the edges of the painted area. The alkyd modification provides improved flow time compared to straight latex, while maintaining reasonable drying speed. At minute 11, the paint continues its transition from wet to dry state. The alkyd resins provide enhanced durability and weather resistance important for exterior applications on fiber cement substrates. At minute 19, the alkyd modified latex has achieved dry-to-touch status across the majority of the surface. The coating provides excellent protection for the fiber cement while maintaining good breathability. At minute 28, the paint has reached complete surface drying. The alkyd modification ensures excellent long-term performance and resistance to weathering effects on the exterior substrate. Conclusion: this completes our comprehensive 90-minute observation of paint drying across 9 different surface types and coating combinations. Each substrate and paint system presents unique characteristics that influence drying time, appearance, and final finish quality. The methodical observation of these processes demonstrates the complex interaction between paint chemistry, environmental conditions, surface preparation, and application techniques in achieving optimal coating performance across various substrates and applications. Thank you for joining us on this detailed examination of paint drying processes. We hope this comprehensive guide has provided valuable insights into the fascinating world of coating application, curing mechanisms, and the scientific principles that govern the transformation of liquid paint into durable, protective, and decorative finishes. Good night, and may your rest be as peaceful as watching paint dry.